Welcome back to this prep for calculus. We ripped through a few different topics yesterday. We ripped through solving right triangles, reference angles, something to do with logarithms, basically compounding, exponential growth and decay, but it was compound interest, the word problem. Is exponential growth and compounding interest the same? Similar, right? It's got an exponent in the power of an exponent. I don't know. That's an interesting question if they're the same or not. I don't think they're very similar. Maybe that its compound interest is sliced up, whereas exponential growth is continuous. I don't know. Something along those lines. Anyway, let's get back on topic, or not on topic, but what was the fourth topic? Trig identities. Simplifying trig expressions with trig identities. Three types of trig identities. Reciprocal identity, reciprocal division, reciprocal quotient. Reciprocal identities, right? Sine equals 1 over cosecant. Cosine equals 1 over secant. Tangent equals 1 over cotangent. Cosecant equals 1 over sine. Secant equals 1 over cosine. Cotangent equals 1 over tangent. Then we talked about quotient. Then there was quotient identities. These are all quotient identities. Tangent equals sine over cosine. Cotangent equals cosine over sine. Those are quotient identities. And then there's Pythagorean identities. Sine squared plus cosine squared equals 1. Cosecant squared plus 1 equals cotangent squared. Secant squared plus 1 equals tangent squared. That's it. Those are fundamental identities. Three groupings of fundamental trig identities: quotient, reciprocal, and Pythagorean. Pythagorean. Good. Something I forgot here. Reference angles are always positive, and change of base formula. You got log base, let's say log base A and then B. Then it is log base X, A divided by log base X, B. Okay, I'll continue learning now and I'll be back to recall what I learned in a little bit. All right, I finished the rest of the topics on exponentials and logarithms. So I also did learn that exponentials and exponential growth and compound interest are like the same thing, except for compound interest is discrete, exponential growth is continuous. So we did some more problems with basically compound interest. Then we did a topic about natural logs. Natural logs, or ln, are logarithms to the base e. E is like basically a value like pi. It's an infinitely repeating number. And natural logs, more of that exponential growth and decay. Then we started learning about rational expressions, because that was the next weakest area. Rational expressions are essentially fractions in which the numerator and denominator are polynomials. So within that section, we were learning about square root multiplication, which I don't understand why that's a rational expression or in that grouping, but multiplying radicals or square roots, square root multiplication. Basically, you just gotta remember that the square root of a times b equals the square root of a times the square root of b, which means, say you have square root of 5, square root of 10, you multiply them together, it's the square root of 50. All right. Simplifying square roots, which I haven't done in a while either, with the prime factorization, I think. Algebraic expression versus fraction. Both numerator and denominator are polynomials. Natural logarithms. Change of base was actually another topic which I learned yesterday, and I did get it wrong. This is how I'm going to remember it. Change of base. The base is on the bottom. So both the numerator and denominator have a base with the same, or log with the same base, but the base of the original is on the bottom. That's how I'm going to remember it. So, yeah, logarithms much better now. They clicked again. So that's it for today. Talk to you tomorrow. See ya.